Okay. Good news today. I'm not using my laptop, so the slides are up right away. And what I want to talk about is how do we go from scientific intent to workflow? So not necessarily the bottom line code, the scientific code, but really from an intent that you have in your head to the structure of a workflow, like something that you can give Pegasus to execute. And Pegasus is a workflow management system that we've been developing since 2001. It's being developed in close collaboration with the HT Condor team. And in fact, we rely on the Condor stack on Dagman to be our workflow execution engine, to the Condor SCAD to do the job submission, to the various resources that you see on the right, so the HTC, cloud, HPC resources. Now, on top of this infrastructure, we put Pegasus, which takes an abstract workflow, which is resource independent, and then maps it onto these available resources to the user. It generates the DAG, it generates the submit files, and so forth. So because this workflow is resource independent, it is portable, it's reproducible, you can share it with others. And so you can also, since it's also explicitly shows the data flow through the system, you can also do data management on behalf of the user. So we infer data transfers, move the data around where it needs to be for the execution. We also do other things on behalf of the user. So we can do automatic task clustering. If a small task, we cluster them into larger entities. We do workflow level checkpointing so that you can resubmit, even if a workflow fails midway, you resubmit the same abstract DAG and the system will know which things were already done, and it can remap the rest onto a different resource, for example. We do data reuse, again, reusing the data that's already been computed. And we can also reduce the data footprint because we analyze which part of a data set is no longer needed while you're executing. And we have also monitoring the dashboard and so forth. So you can run it on your laptop, on a hosted node, or in open on demand. There are a number of different application examples that I have here. LIGO is one of them, also Xenon NT, the Southern California Earthquake Center, and the slides are online, so you can look at others. So what we're trying to bridge is this cognitive disconnect between what the scientist has in their head and can put on a whiteboard, on a napkin, and then to something that Pegasus expects. So the code that generates the workflow that you see on the right. So this is the code for the EHT pipeline that the scientist has generated using the Pegasus Python API. But the way they want to think about this, and also they want the students think about it, is these boxes that you see on the left. So Komal Tareja from Renzi, who I called our AI magician, has been working on this problem, trying to figure out how we can bridge this chasm between intent and the workflow. So first of all, obviously, we already talked about this in previous conversations. We have a faster start, so you don't have like the blank page problem. You can start creating something right away. You probably have fewer errors. You don't have syntax errors and others. It's more accessible, so anybody can use a chat. And it also enables small team science. So if you don't have a big group of people that work on the same problem, AI can be your assistant and improve your productivity. So one strategy that she tried was prompting based on a known pattern. So we've been around for a long time. We have a lot of examples from different science domains of workflows that worked in the past. So you can take an earthquake workflow example where you basically take data from a repository or from the sensors where the sensors deposit the data. You do some data processing, you do some prediction, and then you have the results. So the same type of pattern can be applied to the question of air quality. So you give it that example workflow, you ask it to generate an air quality workflow with particular types of elements that you want in it. You can also take this pattern, you can expand it, you can add nodes just through prompting. We also did an example, we did a number of examples with these patterns, but one also from soil moisture analysis. So this is something that you fetch the data from the soil moisture sensors, you analyze it, again, you train a model that can then predict whether you should irrigate your tomatoes or not. And we validated this model with the SAGE testbed soil moisture data. So you can take the data from this particular testbed and do this type of analysis. Now, so the question is, I was curious whether you can take something that somebody writes on a napkin, on this case on a piece of paper, and can you ask ChatGPT to create a workflow for you? So you, well, ChatGPT is pretty confident and says yes. So but it recognizes the boxes as files. It recognizes the ovals as transformations. It understands the fanouts and the arrows, the input-output dependencies. It can also start thinking about sketching that workflow, and you can ask it to, so it identifies what the various input files are. It understands that you're doing an FFT that produces tiles. You can ask it to draw the workflow for you. And I noticed that one thing it did, the graph of the workflow was very sketchy indeed. And so instead of taking each file and running an FFT on each of these files, it kind of clumped it together. But that's OK. You can talk to it and change that mode of have it a pipeline rather than a combining of FFTs. Now, so these are nice examples, but we wanted to take a step back and think about what are the different ingredients that scientists start from when they're trying to design the workflows. So I showed you they can have a sentence. They want to have a soil moisture workflow. They can have a napkin sketch, but oftentimes they have a published paper. So Brian showed his paper on class ads. So you can have something like that you can start from. It could be your paper. It could be somebody else's. We also talk about Nextflow, and you have an example of these. NF Core has tons of different types of bioinformatics workflows that you want to run. For example, you can SnakeMake has others as well. You have Python scripts. That's very popular. So lots of people have very complex Python scripts that nobody understands today, or you have a specification document. So you have all this stuff, but what Pegasus requires is actually using a Python API, R API, to generate the workflow. You need to build additional catalogs, tell Pegasus where the data is, where the computations can take place, what your resources are. And you need to containerize everything. So we heard that that's a barrier to some users as well. You need to configure contour profiles. So a bunch of things that you need to do. And it takes weeks to learn all that stuff and to do it well. And it takes, so that's a lot of effort for somebody that might not be computer savvy. So the solution that we took to this problem, or Kama did, is to use Cloud Code, or you can use Codex as well. And basically, she generated a number of skills that not only need to generate the workflows, but also to debug them. Also skills that allows you to put your codes in a container, allows you to review things, to wrap code. So all the stuff that you need, all the intelligence that we have in building these workflows, putting it down in the skills that Claude or another coding agent can use. So then she took and she developed these skills based on the taking different patterns that I showed you before, napkin workflows. She took a paper on sea ice surface. We're working with a scientist to make sure that the results are valid on that, and we have a call on Friday to talk about this. She took a number of workflows from Nextflow and converted to Pegasus, so you can run it through the system, and they generate the correct results. SnakeMake as well. We also used scientific codes from our collaborators and looked at using, again, these tools to break up the scripts into workflow components and run them through the system, and validating these as well, and then specs and so forth. So having all these different skills allows you to input your intent in a number of different ways into the system, And as a result, you have a production workflow. You have also the various scripts that you need to run. You have the Docker containers. You have all the catalogs and a README file, how to run the system afterwards. So you have basically everything you need in a readable format, and also the format that Pegasus takes it to Dagman and then HTConda for execution. Now, so Kamal is very productive. In 15 days, she built 14 workflows. She used about 190 different prompts to do it, and it costs about $90 in APIs. But so this is, and again, I want to emphasize, I don't advocate generating the scientific codes that go into the workflow steps. What I advocate for is to use this methodology to develop the workflows that are actually much easier to inspect by a user than the codes themselves. Let's see. Okay. So just to give you an idea of how these things look like. So this is a scaffold skill that tells the agent what are the reference materials that they should use. So you're grounding this discussion. It talks about how to gather the requirements from the user. So ask it about the data sources, the pipeline steps, and so forth. It also helps with this pattern matching. So it says, it gives a number of different reference workflows, and it tells if you have a workflow that does a machine learning training and then prediction, use this example from our repository. It talks about how to generate the workflow name, so simple things. And then it has a whole validation checklist, right? So before the user actually receives the workflow, this workflow will be validated in a number of different steps. The other thing that Kamal has shared with us is that the way she used to basically prompt the Claude to death, then she used to put a huge context and different things, and things were not always working out as she predicted. So the way that she does things today is that she prompts Claude for a design. So she tells it to write a specification document, which is human readable. And then the human reads this specification document and make sure that they agree on what's in that document, what are the files, how the codes will be invoked. So all that stuff is readable. And then you iterate on the design. So for example, if I've seen that FFT that takes a number of different files instead of taking one file at a time, I can correct it at that level. So I don't correct it in code. I correct it at the specification. And once I'm happy with it, you can give it then a prompt to build the workflow for you. So as a result, you have then the workflow that you want to, that's valid. Also, it's something that you can share. You don't share the workflow, you share the specification. So that somebody else can maybe change their codes or do something else and generate their own workflow. Obviously, you can also share the workflow too. And we've proven it in practice with various types of applications. And the takeaway from Kamal is that the human owns the design and AI does the implementation. If you want to know more about how Kamal does things, so she gave a webinar last month in CI Compass. You can go to our CI Compass website and you find the video of that webinar. It was very popular, so she's doing actually part 2 because she had also a lot to share. So if you want to look at the website or just see under contacts how you can follow us on LinkedIn, and you'll see all the webinars that are being shown. All right, so also we're doing, so that's a front end, but now you're running things and you have ugly things coming back from Pegasus. So Mats has been thinking about how to improve our interface on that side of the house. So you see on the left, that's the type of information that Pegasus gives you. It also pulls information, Condor information into which is not shown here, but pulls all the Condor Dagman errors, anything that it sees during execution. And obviously, that's not necessarily user-friendly. So then on the other side, Mats is using AI to generate a more human-readable thing. So it talks about what happens if a particular file didn't exist. It talks about the root cause, so the file is missing under the specified path. It also tells you what are the next steps and how to fix it. And it also tells you that it will likely work if you fix that. So what we're doing in the next major release of Pegasus, we're not replacing the original debugger, the Pegasus analyzer. So we're still providing that. I think mostly because Matt doesn't trust AI. But we're also providing the AI analysis of that error to hopefully help the user. The other concern that Pat has, and maybe now I should have changed his image to a frown, so maybe I'll do it for the next iteration of this talk. Como is great at generating new ideas, generating new things, but then Matt has to think about how we deploy this in production. So the concerns are that we started with a software which was pretty lightweight. The user could install it on the laptop or use it in one of the hosted environments. But now we start to own more of a software stack. So we have to think about how we operate the inference to support all these different AI use cases that we're coming up with. In some cases, we also want to do not only inferencing, but we also want to train Pegasus to use resources better, so learn from anomalies that we see in the system, predict and adapt the workflow when it's being generated. So now we have to do some training as well because you need to learn over time. We need to be able to provision all these different services and have access to GPU infrastructure. And mostly, we also start owning duties of providing these hosted environments of these infrastructures for the users. And that's not something that we've been doing in-house. So and obviously, there are issues of whether you're using your own agent, if you don't have your own agent working for you, how do you provide one? So there are a number of different issues. And obviously, cybersecurity also comes into play in all this. So where we're heading, I think despite some of these concerns, we're trying to work them out. So people have ideas of how to do this well. We're happy to talk to you. And I'm sure I know there's a lot of expertise in the house how to do that. But what we're heading towards is a Pegasus Studio that basically presents the user with an environment where they can use Jupyter notebooks to do the science. They have chatbots included to help them design the workflows. If you like your terminal, I know there are people that like that. It's still provided within the system. So we are providing an environment where your user now has a workbench to create these workflows and suck in whatever codes they want for the science. And the codes, we assume that the science codes are vetted by the user. So they're responsible for making sure that the codes and ultimately the workflows that they run are correct. So in summary, AI models make it very easy to create new science products. But really, the validation verifications are hard. It's a little bit easier when we're talking about workflows because you're talking about high-level recipes that have the science code inside. So if the science codes are correct and you can inspect the recipe, the outcome is likely to be correct as well. But we are very interested in understanding, in general, what kind of tools do scientists need to make sure to validate the outcomes using looking at the workflows themselves, but also ultimately looking at the codes. And we need to think about how they inspect the various outputs, the models that they use, because they're using many more AI models in the processes. Development issues. So again, we worry about infrastructure, FinOps, and cybersecurity, and so forth. And so I would really love to collaborate on these issues and see how far we can get. We're talking with Doug at lunch about now with AI, we can actually start making use of a provenance information that the workflow management systems track, because you can inspect it much easier and query it with natural language. You don't have to worry about what kind of queries the user could ask. The user can ask queries today. And so if you're more interested in Pegasus, I also left the website online. Thank you very much. I'm happy to take questions if there are any.
Thank you, Ewa, and thank you, and Matt, for bringing up the cost aspect that I've been sort of keeping my tongue from the previous one. So what are your thoughts that every time we say we go to AI, a quarter goes down somewhere, and that's the price today. How should we go about it? I also like the comment that you made. I mean, you had the $90 cost, and that's usually we don't see. So it's to you and everyone else. How should we go about it? And tomorrow the cost can be much higher. So
yeah, so there are various answers to that. So in answering the last questions, there are also open models, right? So there's out of Allen Institute, they're putting out OMU and other models that are open and don't cost in terms of tokens, but they do cost and hopefully the federal agencies will support deploying these open models on cyber infrastructure so that the community can use.
So how good are these models going to be compared to the professional models?
So I think they have some ways to go, but I think they're getting better just as the other models are. And they do have the science intent in mind. So they're designed for scientific processes. So I think I'm hoping that
hoping is better.
And the other answer to you is, we're using Google, we're using all these different platforms that already cost money, right? It's just we see.
Yeah, I don't want to go there because they are giving it to you for free today, and they are taking advantage of you by doing it.
Right.
So they, because you mentioned cybersecurity, if I tell a commercial system, that's the workflow I'm working with, and that's the name of my application. What does it mean in terms of IP? I'm staying away from it, but I like the fact that you are stressing the cost. And you're making it explicit.
Okay, thank you. I know you had the question then.
Yeah. Oh, yeah, it is. Yeah. Great talk. I was interested in understanding how folks like myself, RCF, system admins, can integrate sort of the institutional system level knowledge that we know when optimizing a workflow for the OS pool into something like Pegasus AI so that it might spit out a workflow that runs, but there might be a better solution to getting it to run on a particular system.
Yeah, so I think in the solution we have today, it's through the skills. So you can give skills of how you create the conda submit file. So as a result, we ultimately will create conda submit file. So I think we do that, we give the hints for the profiles in Pegasus. So basically how to set these profiles that are quite numerous and unwieldy, having skills there that can translate, will help that translation. Thank you.
So Miron gave me an opening to a shameless plug. So we're running about a dozen open models that you can freely pick from for free. Via NLP, you can access them. We have right now a typical usage of about 35 billion tokens a month, peaking at around 20-ish, 25 billion tokens a week. I intend to keep that open for as long as I can, probably as long as this is interesting. Now, the open models that we adopt, new open models anytime they come out, my sense from looking what the pundits say, is that open models are about 6 months behind the best models that come out of the Anthropic and so forth. My sense is also that the vast majority of people who today use their credit card to go to Anthropic are wasting their money, because they would be better off doing it in the open models because they're no worse. In terms of security, if you go to a place that runs it themselves, you're guaranteed that your data goes nowhere, because by definition, it goes nowhere. That's one alternative of swinging this. And in order to make this scalable, we're pursuing 3 different strategies. Strategy number 1 is NRP allows you to simply buy a piece of equipment that we then operate and put into the pool. So that means that you can buy yourself out of this problem by buying hardware that we then operate whatever is the latest models on, and you have guaranteed capacity. So you've bought yourself capacity. Model 2 is that we're working with NAIR right now to make this a NAIR allocable service. There's sort of dots to be dotted, I's to be dotted and T's to be crossed, but similar to what NAIR already has, which is OpenAI as an allocable service. The same concept would apply to anybody who runs this for the NSF. And so we're intending to run this for the NSF, in essence. Now, once you do that, then you can put any hardware in that the NSF has. We operate this as a scalable distributed system, meaning I can actually say, I'm going to take existing GPUs out of NAIR, add them into this service, and therefore scale that service to arbitrary sizes. We're using infrastructure software to implement this service that come out of industry and are open source. There's an entire ecosystem of AI software infrastructure that you can build into. We've picked one and we've changed that over time as new ones, better ones came around. So we support MCP, we support chatbots, we support API calls, we support API calls out of Jupyter. All of that exists and is in use. So I think that the future in this is somehow 3 models. And the 3 models that I see is your own hardware that somebody else, like NRP, operates for you and therefore provides you back the tokens per seconds that you have contributed. That's one model. The second one, you get an API, you get an allocation standard, right? I write an allocation request, voila. And the third one is the path model, that you get some amount of capacity for free and you compete for it. And I think that we can actually combine all of this model, operate on the same infrastructure at the same time, so that when you need more and your allocation has run out, you have a guaranteed access to something that's for free, but that is in the margins, and the bulk of the usage comes from either allocations or ownership. And therefore you have a varied business model that de-risks your usage of AI and makes what you asked viable moving forward into the future. And we'll see, Mazel Tov, as you always say, Miron, we'll see whether this actually gets us to where we want to go.
Oh.
The whole business of inference as a service, that's where the money is coming from, is something that we have to understand. You're basically suggesting a model of I'll do inference for you, whether I host the model or you provide me with the model, and just these servers will do the inference and respond to you on capacity that is one of the 3 categories.
How about we let Tim give his talk and
Having fun, what?
You come up after. You're next after him.